Good afternoon to all. This is Babu. Today we are going to discuss about the introduction of the electrical measuring instruments. We are going to discuss about the detailed explanation of the electrical measuring instruments. First of all, you know about the what is electrical measuring instruments. Okay, this is one of the device. The device is used for the measuring the unknown quantities. These instruments are used for measuring of electrical quantities like current, voltage, power, and energy, etc. This means the unknown quantity can be measured based upon the comparison with some standards. That is the known quantities. The unknown quantity can be measured based comparison with the known quantities. So such as called measuring instruments. Such a device is used to measure the electrical quantities, nothing but the electrical measuring instruments. That electrical quantities are the voltage, current, power, energy, frequency, etc. Okay. So what are the different types of measuring instruments there? The measuring instruments mainly classified as two types. That one is the absolute instruments and secondary instruments. Okay, absolute instruments is the instruments does not give direct reading, does not depends on the direct reflection of the pointer, but can give the in terms of instrumental constant. These are accurate measuring instruments. These instruments are accurate measuring instruments. These are used in the research laboratories. Such example for such type of instruments are tangent galvanometers. The second type of the measuring instruments is secondary instruments. In secondary instruments, the deflection is given the magnitude of the electrical quantity to be measured directly. These instruments are required to be calibrated by comparing with another standard instruments before putting into the use. Okay, that means these are required to pre-calculation. So this type of instrument is directly measured based upon comparison with the standards. So the type of instrument is called the secondary instruments. The secondary instruments are further classified as indicating instruments, recording instruments, integrating instruments. These are the three types of the instruments. And this first one is the indicating instruments. Okay, its name indicates that is the indicating instruments. So that is shows the that can shows the direct indication of the value, direct indication of the values. It indicates the direct indication. That is the magnitude of an unknown electrical quantity can be measured, can be indicated at the time, at the instant. That means when it is being measured at that time, that can be directly indicated, directly measured by a pointer moving on a calibrated scale. So the type of instruments called the indicating instruments. The examples for such type of instruments is the ordinary ammeter, voltmeter, and wattmeters, etc. is the examples for the indicating instruments. The second one is recording instruments. The instruments which keep a continuous recording of the variation of the magnitude of an unknown electrical quantity to be observed over a defined or selected period of time. Okay, that's mean the pointer will be record continuously the continuous variation of the electrical quantity depending on a time. That can draw a graph on XY plane, on XY plane with respect to time. So that type of instrument is the recording instruments. So in recording instruments continuously record the values. Okay, what are the example for such type of instrument means ECG machines that can be continuously record the values, oscilloscope, galvanometers, and voltmeters. So these are the example for the recording instruments. Then the third type of instrument is the integrating instruments. The instruments which measure the total amount of electrical unknown quantity or electrical energy supplied over a particular period of time, but supplied by a period of time. For example, energy meter or kilometer per hour, etc. So these meters are continuously measure the value over a period of time. So that is nothing but the integrating instruments. Okay. Then next one is the essential of indicating instrument. What is the different operating system required to operate a instrument? Satisfactory operation of the instruments means they are the three type of torques is required. Three type of force is required to operate the instrument satisfactorily. They are the deflecting torque, second one is the controlling torque, third one is the damping torque. So deflecting torque is also nothing but the operating torque or starting torque. Controlling torque is the restoring torque. Controlling torque is the restoring torque. Now we are going to discuss about the first one is the deflecting torque. Okay, this torque produces the required amount of mechanical force in the pointer to move from its zero position, and the instrument is connected to the supply. When an instrument is supplied to the supply, the current is passing through the devices. Proportional to this current, pointer will be deflect from zero position. That means the current will produce the mechanical force. So by using this force, pointer will deflect from zero position. Then to obtain this force in an instrument, different effects of electric current uses. Such effects are magnetic effect, heating effect, chemical effect, electrostatic and electromagnetic and induction effects. Due to the supply of current or voltage that can produce this type of effects, these effects will be give the deflecting torque. This effect will give the deflecting torque, so that the instruments will be use any one effect for deflection. So without deflecting torque or deflection force, pointer of an instrument cannot be moved for any value or does not come. So that the pointer will not move from zero position. Okay, that not indicates the any value without deflecting torque. Okay, it is clear. Then next you can go to the another torque or another force, that is nothing but the controlling torque. Okay, controlling torque is essential to control the movement of an pointer. And to ensure that the magnitude of this deflection of the pointer is always the same as given value of the quantity to be measured. So which quantity to be measured, that magnitude values proportional to that magnitude value, pointer will be deflected. Pointer will be deflected. After deflecting of the pointer will goes to infinity position, maximum value, maximum position. Does not stop at the measured value. That's why they can need one force. That force is nothing but the controlling force. This controlling force is always act in opposite direction to the deflecting force. Okay, and also return the pointer to its initial, that is 0 position, when the instrument is disconnected from the supply. Okay, so when supply is given to the instrument, both the force will acted, that is the controlling force and the damping deflecting force will acted. After removal of the supply, pointer will becomes 0 position due to the effect of controlling force. Okay, without controlling torque, the pointer will sink at its maximum position and it will not return to 0 after removing the source. If the controlling torque is failed, the controlling torque is absented, the pointer will not come to 0 position. When the controlling torque is 0, the pointer will not come to 0 position and return to the 0 position after supply will be removed. That's why the control torque is also required. The controlling torque of the system is equal and opposite of the deflecting torque. Equal and opposite force of the deflecting systems. Okay, the control torque is produced either by the spring or gravitational methods. Spring or gravitational methods. So this control torque is given to the instruments. So first one is the spring control method. We see the spring control method. In this system, there we can use the two springs, two phosphor branch springs, that is A and B. The inner end of the springs are connected to the, you see, the inner end of the spring is connected to the movable spindle. You see, they have the two springs, that is twisted or wounded in opposite directions. Okay, the most common arrangement of these two springs is shown in figure. So these springs are made up of phosphor branch. When the pointer is deflected, one spring is unwounds or unwinds itself, while the other spring, so other is this twisted. Okay, this twist in the springs produces the controlling torque that can give the controlling torque to the instruments, which is proportional to the angle of the deflection of the pointer. So that's why the controlling torque is proportional to the theta. Theta means the angle of the deflection of the pointer, but deflect torque is proportional to the current passing through the circuits. Okay, here the control springs. The control springs helps in the two purpose in these instruments. The first one is the spring leads to current. So current will be in and out to the system or coil. Second one is it gives the controlling torque. Okay, this is the purpose of the spring is to give the controlling force or controlling torque to the instruments. Okay, is it clear? Next, gravitation control. Okay. See, in gravitation control instruments, a small in gravitation control, a small adjustable weight is attached to the spindle or movable spindle of the moving system, such that the deflecting torque produced by the instrument has to act against the action of the gravity. Okay, so this both the balancing weight and the controlling weight is attached in the opposite direction. Similarly, this also attached to the spindle in opposite to the spindle pointer direction. Thus, a controlling torque is obtained. This weight is called the control weight. Another adjustable weight is also attached to this spindle, movable spindle for zero adjustment. That weight is nothing but the balance weight. That is also shown in this figure. Okay, so this can be used in the vertical position only due to the use of the gravitational weight. Okay, then third force. Third system is the damping systems or damping force. Okay, we have already seen the two type of force or two type of torque. That is the deflecting torque and the controlling torque. Okay, so the moving system, the instrument will be indicate the value based upon the movement of the deflection of pointer. The pointer deflects proportional to the magnitude of the current passing through the devices, or current passing through the circuits. Due to the acting of these two forces, that is the damping force and the controlling force, with the movement of inertia of the pointer will be oscillates along its axis at final position. That's why pointer will not come to rest quickly. So there is more time to measure the value. That's why this can be reduced. This can be overcome. This oscillation force can be minimized by using the damping system or damping force. Okay, so you see the diagram of the damping systems. There are the three type of damping forces there. One is the under damping, critical damping, over damping. You see, under damping. In under damping cases, the pointer will come rest with that can take more time. You see, this is the under damping systems. The pointer will become rest position with some times. Next, over damp. In over damped cases, the pointer will become rest sharply, very quickly. You see, this is the over damped system. In critical damping systems, the become rest position moderately is called the critical damping system. This is the different type of the damping system. What are the methods to produce the damping torque? So there are the three type of the method is there. One is the air friction damping, fluid friction damping, eddy current damping. Okay, these are the three type of damping systems is available in the measuring instrument.